Now we are starting with the IUPAC, that's how we can write the name for the coordinate complexes. So you should know that the name is written in two parts. It is divided into cation and the anion. That means first the cation is named, then followed by the name of the anion. So cation is always named first and then the anion is named. So as you all know, cation is positive, anion is negative part. So always the positive part name is written first and then followed by the negative part name. Then we have ligands there, right? Ligands can be similar, can be dissimilar. But if the ligands are dissimilar, what you do, you just name them in the alphabetical order. For example, you have amine, you have aqua, you have this thing ethane 1,2-diamine. So just use the alphabetical order in writing the names. And if the same ligand is present in if the same ligand is present in 2 times, 3 times, so just prefix the di, tri there. But if di, tri is already used in name, so instead of that you can use base stress like that. So, but you need to use that because to indicate that whether the same group is present in 2 number or 3 numbers, so you need to prefix di, tri or base stress before the name of the ligand. And if the complex part is the anion, like for example, suppose I have this kind of, let's say if it is like this, if it is anion, then the name ends with IUM. The name ends with, if the complex part is anion, the name ends with 8. The name ends with 8. And for the cation, it remains the same. Number of anionic ligands, like if there is the ligands which are present is the anion, that means the negative ones, their name ends with O, like chlorido, fluorido, like that, right? And for the cationic ligands, it ends with IUM. Right. So keep in mind, don't get confused when we are talking about complex part. If complex part is, the whole complex part is cation, it is named with as such, and if it is anion, its name ends with 8. But when we talk of ligands, if ligands are anionic, their name ends with O. So if complex part is anion, 8. If anionic ligands are there, then O, and name of the complex part is cation as such, and if the ligand is cation, it ends with IUM. Right. And for neutral molecules, it remains same like aqua, amine, carbonyl, nitrosyl, like that. And oxidation state is always indicated by Roman numerals, right? Like for example, you will be writing the ligands first followed by the central atom, and then you need to put the oxidation state for the central atom in the Roman numeral, and then you will be writing the name for the anionic part. And then name of the complex part is written as one word, like the first you will be starting with the complex part if it is cation, then followed by the anion, and in the middle you will be writing the oxidation state. For example, let us take this thing. So in this case, like first we will take a simple one. It is K4FeCN6. In this is a cationic part, and this is, you know, is a anionic part, right? As I told you, we are going to write the name for the cation first, right? So it is potassium, right? This is 6. Then we are going to write the name for the ligands. It is hexa, cyanido, because it is a negative ligand, anionic ligand, and this is fer, and we know that whenever the complex part is anionic, we are going to end the name with 8. So it is ferrate. And what is the oxidation number for this in this case? We already found it comes out to be 2, so just put 2 here. So this is actually the name for this compound, that is the potassium cationic first, then the ligands hexacyanido, and then ferrate, because it is it is going to be a negative complex part, ferrate followed by the oxidation state for the central atom in numeral. Likewise, we will be taking this thing also in a similar way. So here we have, we will be writing it is going to be a positive part and it is going to be a neutral part, right. So how we will be doing it? We will be writing silver diamine, because it is a neutral molecule, right, and then followed by the oxidation state here itself, followed by dicyanido, like this.